Welcome to Maths Olympiad preparation classes. This is mainly from our class 8th to class 12th students who are preparing for Maths Olympiad. Okay. This is part 12 of the video. You can see my playlist for other videos for the preparation. And in this video, along with other problems, we will learn the concept of Euler's Totient function and how can we use it. Okay. Let's get into the problems. Find the remainder when number 10 to the power of 10 plus 10 to the power of 100 plus 10 to the power of 1000 up to 10 to the power of 10 to the power of 8 is divided by 7. Okay, basically 8 terms. Okay, we need to find the remainder when divided by 7. So yeah, this is the basic problem. For those who are already know the congruence and remainder theorem, I think this is very easy. Okay, so how to find this one is first find out a general number and then apply it for each term. Okay, so let's take, how can we write this 10 to the power of 10, 10 to the power of 10 square, 10 to the power of 10 cube up to 10 to the power of 8, correct? Addition of all these terms. If I find a remainder for 10 to the power of 10, then rest of them is very easy, correct? So let's do. 10 to the power of 10 is equal to, I can write it as 10 square whole to the power of 5. Why I am writing 10 square? I need to find out nearest a number which is near to 7 table, right? Okay. So 100, if I 100 mod 7 is 2. Okay, in 7 table you have 98. So 100 mod 7 is 2. So it will become remainder is 2 to the power of 5. Correct? So now 10 to the power of 10 when divided with 7. Okay, 2 to the power of 5 is the remainder which is congruent to 4. Okay, 2 to the power of 5 is 32. So 32 divided by 7 you get remainder 4. Okay, so now we find for 10 to the power of 10. Now you just apply for the squares and cubes and up to the power of 8. So 10 to the power of 10 to the power of 2 congruent to 4 square. Okay, mod 7 which is congruent to 2 mod 7. Okay, 2 is the remainder here. 10 to the power of 10 to the power of 3, 1 is the remainder. Okay, similar way, 1 is the remainder. Okay, when you divide it with 7. Okay, then 10 to the power of 10 to the power of 4 is nothing but I can rewrite this as 4 square into 4 square, correct? Okay, which is nothing but 2 into 2, or you can directly do if you want 4 to the power of 4 value find out and divide it with 7 and then find out module. Okay, but once you know the rules of congruence or remainder theorem, you can easily apply them, right? So 4 square into 4 square, I can write it as, okay, and 4 square we already know 2 is the remainder, so 2 into 2, so which is 4 again. So it repeats actually. This is the cycle which repeats. 10 to the power of 10 to the power of 5, you get 2 remainder. 10 to the power of 10 to the power of 6, 1 remainder. Okay, it repeats actually, but if you want it's only 8 terms, you can just find out. Okay, so now the sum of the all these values is 10 to the power of 10 plus 10 to the power of 10 to the power of 2 up to 10 to the power of 10 to the power of 8 congruent to 4 plus 2 plus 1, 4 plus 2 plus 1, 4 plus 2, 8 terms. Okay, carefully write it. Okay, if you sum up this and divide it with 7, you will get a remainder 6. So 6 is the answer. Okay, hope you understand this remainder problem. Next. The product of two positive integers is 9984 and the greatest common factor, which is GCD or you can call HCF, of those integers equals the difference between them. What are the two integers? Okay, so we know that there are two integers which have a common factor, right? Greatest common factor, which is, let's say, G. Okay, then directly we can assume the numbers as Gx and Gy, where x and y are relatively prime, and G is the GCD of those two numbers, correct? So let's assume, let the numbers be Gx and Gy, where x and y are co-primes and x is greater than y. You take this condition, okay? Then Gx into Gy, which is equal to G square xy, which is 9984. Okay, that if you write in prime factors, it is 13 into 3 into 2 to the power of 8. Okay, so now GCF of Gx and Gy is G, which is equal to Gx minus Gy, which is given. It's equal to difference between those two numbers. Since x is greater than y, we can say Gx minus Gy. Okay, which means if I cancel G on both sides, I'll get x minus y equal to 1. This is my first condition. Correct? Next. We have two conditions here now. Okay, x minus y equal to 1, and of course the numbers product of numbers is 13 into 3 into 2 to the power of 8. Okay, you can consider that as other condition, right? So now G is possible only with 1, 2 square, 2 cube and 2 to the power of 4. What is the meaning of yeah, this one? You understand carefully. If gx and gy are relatively prime, then 1 is its GCD. If they are not relatively prime, then it has to be only split with the 2 to the power of 8. Correct? From 2 to the power of 8, I can split. I need two terms, right? I need two equal terms, which is two squares. Two squares I can make. Two cubes I can make. Two to the power of 4 I can make. No other number is possible. Correct? So GCD is only these four numbers it is possible. Correct? Now it's a problem of checking all the conditions with this four values for the GCD. So let's come from highest to lowest. Okay. Let's assume that G is equal to 2 to the power of 4, which is 16, which means G square equal to 2 to the power of 8. So XY product of X into Y equal to 13 into 3. Okay. So whatever combination you take here, X minus Y, you will not get equal to 1. Correct? That's not possible. So GCD cannot be 2 to the power of 4. Okay. So next, GCD equal to 2 to the power of 3, which means G square equal to 2 to the power of 6 and XY equal to 13 into 3 into remaining values 2 to the power of 2. Okay. So in this case, 3 into 2 to the power of 4 is 12. So X can be 13, Y can be 12. Right? There is a possibility where X minus Y equal to 1, which means this is a possible combination. Correct? So X minus Y satisfies with this, X equal to 13 and Y equal to 12. So the two numbers are 13 into 8 and 12 into 8, which is 104 and 96. These are the two numbers. Okay. Yeah. Next. Cozy the cat and dash the dog. Okay. C for cat, D for dog basically are going up the staircase with a certain number of steps. However, instead of walking up the steps one at a time, the cat and dog, they jump actually. Okay. The cat goes 2 steps up each time. Okay. And the last step can be either 2 steps or whatever the remaining. It can be 1, it can be 0, right? It can be 2, right? 0 means as good as actually 2 in the previous step, correct? Now dash also jumps, goes up 5 steps at a time, and the last step can be anything less than 5. Okay. Suppose the dash takes 19 fewer jumps than cozy, that is cat. To reach the top of the staircase, let S denotes the sum of all possible number of steps that staircase can have. What is the sum of digits of S? Okay. So the problem looks very big, but this is very simple if you try to break down the problem. Okay. So cat jumps 2 steps at a time and then remaining steps in one go. Dog also jumps 5 steps at a time and remaining in one go. Right. So number of staircase steps are constant. Correct. Now number of jumps dash takes is 19 fewer than cat. Right. So this is the information which is given, which you put it in formula, you will easily understand it. Okay. So let's see. Let the cat take total of C steps and dog takes D steps. Okay. So C is equal to D plus 19. Correct. Dash takes 19. That is dog takes 19 steps less than cat. Correct. So C is equal to D plus 19. Now C into 2 minus X. Okay. C into 2 minus X is equal to, okay, 5 into D minus Y. What is the meaning of this one? Okay. So cat takes 2 steps at a time. Correct. Cat takes 2 steps at a time. Okay. And last step can be number of jumps, this is right. And one step out of the C, the last one, Cth step can be anything between 0 and 1. Okay. So I need to subtract the remaining. It can be either 0 or 1. I will subtract so that I get the total steps. Okay. Which is equal to dash takes 5 steps at a time. So if I multiply with the 5 total number of steps, I'll get more than the total number of steps, right? Just like 2C is greater than total number of steps, 5D is also greater than or equal to the total number of steps. Okay. I need to subtract the last step what dash has done. Okay. Either it can be 0 steps, 1 step, 2 steps, 3 steps or 4. It can't be 5. 5 means already covered in 0. Okay. D plus 1 it will become, right? So this is my other equation. Okay. Now if I convert it to one variable C or D basically. Okay. So this will become, I am substituting C equal to D plus 19, then it will become 2D plus 38 minus X equal to 5D minus Y. Okay, which if I simplify, I get 3D minus 38, 3D minus 38 plus X minus Y equal to 0. Okay, now what I have to do, there is one equation, 3 variables, how to solve, don't worry. Okay, X is ranging from 0 to 1, that's it, integer value, and it can be either 0 or 1. And Y can be 0, 1, 2, 3, 4, that's it. right? So make a simple table to find out the values of D which will satisfy the condition. That's it. Right? So if I take x equal to 0 first time, then y is having 5 values 0, 1, 2, 3, 4, 5. So D is possible first of all. D and C is, this is not a possible combination. Okay, because if x and y are zeros, 3D equal to 38, D cannot divide, D you cannot get an integer value for D, correct? 38 by 3, there is no integer value, so it's not a possible case. 0 and 1 if I take, okay, then 3D equal to 39, D is equal to 13, correct? If D is 13, C will be 32, okay, and S is 64. This is a possible value, integer value is possible, okay. How I am getting S? S is nothing but either you can take C into 2, okay, or C into 2 plus X basically, okay, or D into 5, D into 5 which is 65 minus, sorry, not plus X, minus X there also. So D into 5, because 5 steps at a time, minus 1, okay. Now, if x is 0 and y is 2, you don't get any integer value for D. Similarly, you get other options which is for 0 and 4, x and y, x equal to 0, y is 4. You get 14, D is 14, C is 33, and total steps are 66. Okay. Similarly, if you take x equal to 1 and y equal to 1, 2, 3, 4, 5, only for y equal to 2, you get an integer value which is 13, D is 13, C is 32, okay, and S is 33. Sorry, 63. So now I have three values, right? So my, from the table, sum of possible total number of steps is 64 plus 66 plus 63, which is 193. Now the question asked is sum of digits of S, which is 1 plus 9 plus 3, which is 13. That is the answer. Okay. Hope you understand this question. Next. What is the area of the region enclosed by the graph of the equation x square plus y square equal to absolute x plus absolute y? Okay. So first thing is, you look at the equation given x square plus y square equal to absolute x plus absolute y. If you remove the absolute there, let's say, this will become x square plus y square equal to x plus y, which is a equation of a circle, correct? So definitely we can make this into the equation of a circle and then see what happens. Okay. So x square plus y square equal to absolute x plus absolute y, which means x square minus absolute x plus y square minus absolute y equal to 0. Okay. Then I want to write in x minus a whole square, right? So I need to add half square and half square for x and half square for y, and on the RHS side I will add half square plus half square I will add, okay, to cancel the whatever I added on the LHS side. Okay. So this looks like now absolute x square, I can write it as absolute x whole square, right? So absolute x minus half whole square plus absolute y minus half whole square, which is equal to 1 by 2. This is nothing but 1 by 4 plus 1 by 4, which is 1 by 2. So that is 1 by root 2 whole square. Now this looks like a circle equation where center is at, correct? Center is at 4 circles basically. Okay. Center is x comma y is equal to plus or minus 1 by 2, comma plus or minus 1 by 2, and radius is 1 by root 2. Correct? So these are the four circles in 4 quadrant whose center is in first quadrant it is half comma half. Here it is minus half comma half, minus half comma minus half. Okay. Then here my half comma minus half, right? And 4 circles are enclosed, and I need to find out the area enclosed by this region. That is nothing but if I take all semicircles are actually cut here like this. Okay. So you have a semicircles, 4 semicircles. Okay. And then a square in between, right? This square is nothing but diameter of the circle. Since all the circles are of same diameter, you can take any circle diameter, and then this is my side of the square. So area of the given shape right, graph is nothing but 4 semicircle areas plus area of the square, which is nothing but 4 into 1 by 2 into half into 1 by root 2 whole square, because 1 by root 2 is the radius of this circle, plus 2 by root 2 is the diameter whole square, right? A square is the area of the square. So if I simplify, I'll get pi plus 2. This is the area of the graph enclosed by x square plus y square equal to absolute x plus absolute y. Okay. So hope you understand how to solve this geometry problems like this. Okay. Yeah. Next. Yeah, let us learn the Euler's totient function, which I mentioned actually. This is represented as phi of n. Okay. Now this is nothing but a counting co-prime numbers. Okay. So what is this? We'll see the definition. Okay. What is phi of n or Euler's totient function is? It counts number of integers which is less than or equal to n that are co-prime with it. Okay. So if I am counting for phi of n, then I need to find all 0 to n minus 1, sorry, 1 to n minus 1, how many co-primes are there? That is the count which is given by this phi of n. Okay. Now you may think, okay, there are so many counts like this are possible. What is the use of this one? Okay, that we will come to know. Okay, use of application of this will come to know. Okay, but you hope you understand the definition of Euler's totient function. And for your information, this usage of this one is coming in IOQM and Math Olympiad problems across actually. So it is very important to learn and know about it. Okay, this is a very simple function. We know it, right? So example, phi of 15 means I need to find out all the co-primes from 1 to 14 with 15. Correct? There are total 8. What are the 8? 1, 2, 4, 7, 8, 11, 13, 14. Okay, 15 cannot be the co-prime with 15. 3 cannot be. Okay, 5 cannot be. 6 cannot be. Okay, 9 cannot be. 10 cannot be. 12 cannot be. Okay, so hope you understand how to find out the value of this number. But let's just imagine if the number is very big. Okay, phi of some 5,000, 6,000 number is given, then that's a big problem. Or some prime number 13 to the power of 10, some big number they calculated and gave. How to find out? Okay, those are the useful information using Euler's totient functions. Let's see. Okay, so formula for this one is you have to write, okay, you have to write the given number in prime factorization method, that is p1 to the power of a, p2 to the power of b, up to pk to the power of z, let's say. Okay, this is the prime factorization of the given number. Then phi of n is equal to n times 1 minus 1 by p1 into 1 minus 1 by p2 up to 1 minus 1 by pk, all prime factorizations. Okay, you have to subtract like this. You are not interested in the powers, you are interested in the what are the prime factors of this number. Okay, we are not interested in the power a to b, a b c up to z, we are not interested. Okay, now just imagine if the number is already uh, uh, written in co-primes, okay, and there is no powers. Okay, let's say it is something simple like 2 into 3 into 5. Okay, 2 into 3 into 5, or it can be anything, any other number also, into 13, into 17, into 19. Okay, there is no power, there is no repetition of prime factors. Then what happens? Okay, just to see, very simple. Okay, in that case, okay, p1 minus p1 minus 1 here, p2 minus 1 here, up to pk minus 1, and all the denominator is nothing but p1 into p2 into p3 up to pk, which is nothing but n, because prime factorization don't have any power, so the n gets cancelled. This will become p1 minus 1 into p2 minus 1 into p3 minus 1 up to pk minus 1. Okay, so this is one very simple shortcut, but you don't need to remember that. You remember this formula. Okay, prime factorization. First do the prime factorization and then apply this one, you will get the answer anyway. Okay, now example, for 12, I can write it as 2 square into 3. Okay, now phi of 12 is nothing but 12 into 1 minus 1 by 2 into 1 minus 1 by 3. Okay, so how much it is? This is 1 by 2, this is 2 by 3. So if I simplify it, I'll get 4. There are 4 co-primes for 12. What are the 4? 1, 5, 7, 11, if you see. Correct? So this is how you can use phi of n function, and you don't need to count always. That is the important thing. Okay, you don't need to count. You can always derive using this formula. That is important. This is why it is easy to calculate phi of n. Now, only thing is, okay, I can calculate this one, that's fine, but what is the use of this one? What do I do with this? Okay, so that we'll see. And there are some special cases which is very important. Okay, if p is a prime number, then phi of p equal to p minus 1. Okay, so let's derive it from here. Very simple. P is a prime number, so n is equal to p, that's it. So you don't have any of this product. Okay, which is nothing but n into 1 minus 1 by p. Correct? N into 1 minus 1 by p. 1 minus 1 by p, I can write it as p minus 1 by p. P is nothing but n because it's prime. Right? N and p gets cancelled. And then we are left with p minus 1. That is what here. Phi of p is, so phi of prime is, so if you have a prime, every number which is less than prime is co-prime with this. That's why it is called prime, right? So that is the definition. Important thing is this one. Phi of prime to the power of k. Phi of prime to the power of k is equal to p to the power of k minus p to the power of k minus 1. Okay, this is how you can calculate co-primes with um, prime to the power of k. Okay, so this is also, remember, this is the important case. Okay, example, phi of 5 is 4 because 1, 2, 3, 4, 5 are its co-primes, p minus 1 you can do, and phi of 5 square is 25, right? 5 square minus 5 it will become p of k minus p of k minus 1, which is 5 to the power of 2 minus 5, which is 20. There are 20 co-primes, okay, which are the 20 I mentioned here. You can count them. Okay, these are the 20 which are co-primes with 25. Okay, so this is the useful formula for the Euler's Totient function. Let's do some simple questions and then solve some important questions. Okay, if phi is the Euler's Totient function, then what is phi of 92? Okay, so 92 write in prime factor method first. 2 into 46, which is nothing but 2 square into 23. So now phi of 92 is nothing but 92 into 1 minus 1 by 2 into 1 minus 1 by 23, which is 2 into 22. Okay, 2 into 22, that is nothing but 44. There are 44 co-primes in 92. If you start listing them one by one, then you know how much time it takes, right? So this is the useful method. Next, if phi is the Euler's phi function, then phi of 1001 is equal to p, then what is the value of p minus 100? Okay, so this is also similar. First phi of 1001 we will find out. 1001 is nothing but 7 into 143, which is nothing but 7 into 11 into 13. Okay, so now we know that there is no power, so it is obviously 7 minus 1 into 11 minus 1 into 13 minus 1. Correct. So, but let's apply the standard formula. Phi of 1001 equal to 1001 into 1 minus 1 by 7 into 1 minus 1 by 11 into 1 minus 1 by 13, which is nothing but 6 into 10 into 12. So 7 minus 1, 11 minus 1, 13 minus 1. Okay, which is equal to 720. Now this is phi of 720 is what I need to find out. This is what my P is. Okay, so 720 I can write it as 2 to the power of 4 into 3 square into 5. So phi of 720 is nothing but 192. Okay, there are 192 co-primes. Okay, so P is equal to 192. So P minus 100 is 92. That is the answer. Okay, next. Okay, applications in the remainder theorem. This is very important thing to know actually. And this IOQM, this year IOQM, that is IOQM 2025, a problem came in 5 marks question where this is very uh, trivial, trivial to use this formula to solve a bigger problem actually. Okay, problem is bigger. You can go through my IOQM question paper for 2025. One of the question has the usage of this Euler's Totient function. Okay, usage. Okay, I'm not telling that's the answer to find out. Question is not on Euler's Totient function. Question is a bigger question, but this is the way you can use. Otherwise, the number is very big. You cannot find out by your own. Okay, so if A and M are co-primes, then a to the power of phi of m is congruent to 1 mod m. Okay, important terms you see, where is the m? M is mod m. M is also phi of m. Okay, and a and m are co-primes. A and m are co-primes. Then this is applicable. Okay, this is very important to remember. Okay, phi of m is Euler's Totient function. Okay, now let's see example. Find k such that 3 power k leaves remainder 1 when divided by 130. Okay, so exactly this is the one which we use in that question. Actually, I just took it the part of the question and frame a question here. Actually, part of the IOQM 2025 main question, 5 marks question. One part of that question you solve this k value actually for it is in such a way that 3 to the power of k leaves remainder 1 when divided by 130. Okay, once you solve it, you know how difficult it is doing it normal way. Okay, so let's see this. So basically we need to find out 3 to the power of k congruent to 1 mod 130. 3 and 130 are co-primes. We understand that. So conditions are possible to apply the above formula. Correct? Now k is equal to, I will call it phi of 130. Okay? K is phi of 130. So 3 to the power of phi of 130 is congruent to 1, congruent, sorry, that's not equal, congruent to 1 mod 130. Okay, so phi of 130 is nothing but 2 into 5 into 13, which is nothing but 130 into 1 minus 1 by 2 into 1 minus 1 by 5 into 1 minus 1 by 13, which is 48 is the thing, right? Answer phi of 130. So 3 to the power of 48 is congruent to 1 mod 130. See how difficult it is if you manually do k to the power of, you keep trying k equal to 1, k equal to 2, k equal to 3, right? It is, you have to go up to k to the power of, okay, I mean 3 to the power of 48 actually. So that's not so easy to get a number. So these are the places where Euler's totient function actually helps a lot. Okay, so this is one example. Now let's see one problem on it. Find the least odd prime factor of 2 to the 2019 to the power of 8 plus 1. 2019 to the power of 8 plus 1. Okay. So basically question is 2019 to the power of 8 plus 1 is congruent to 0 mod p. What is the p? Is a prime, odd prime basically. Okay. Of course, primes are most of the, except 2, all the primes are odd. Okay. So this is the question. So how can I make it into uh, simple 2 to the power of 2019 to the power of n there. Okay, I take the 1 to the other side. So it will become 2019 to the power of 8 congruent to minus 1 mod p. But if you remember the function, we should have 1 mod p, right? So I will square it. Okay, if I square it, I get minus 1 into minus 1 as remainder, which is nothing but 1. So 2019 to the power of 16. Okay, or it need not be 16, it can be 16n, where is the n is an integer. It can be a square, it can be to the power of 4, it can be to the power of anything basically, right? So 2 to the power of 19 to the power of 16 congruent to 1 mod p. Now if you look at p is the prime, so obviously 2019 and p both are co-primes. Okay, so now my 16 is nothing but phi of p, which is p minus 1, correct? Okay, so remember Euler's totient function, a to the power of phi of m is congruent to 1 mod m, a and m are co-primes. Okay, for prime values of m, phi of m is equal to m minus 1, so phi of p is equal to p minus 1. So my final question is something like a to the power of p minus 1 is congruent to 1 mod p. Okay, so in this question phi of p equal to p minus 1, which is nothing but 16n or 16. Okay, it can be 16 if n is equal to 1. So now I need to solve this problem by taking values for n, okay, where I get a prime, okay, and then substitute into the original one, because we are actually squaring and trying to solve the problem. We may get false alarms also, okay. So you need to check all the values, cross check all the values, just because we are not actually solving the original problem as is. We are actually we did a square on the 2019 to the power of 8, right? So that's why we need to find out each value and cross check. Okay, so let's take n equal to 1. For n equal to 1, okay, p is 17, 17 is a prime, so condition is okay. Check the remainder of 2 to the power of 19 to the power of 8, and it should get, we should get minus 1 as remainder when you divide with 17, correct? So 2019 to the power of 8, okay, is congruent to k mod 17. K should come minus 1, okay. So 2 to the power of 19 mod 17 is nothing but 13. So 13 to the power of 8 congruent to k mod 17, okay. 13 square is 169. 169 divided by 17 is nothing but uh, sorry, yeah, 13 is nothing but minus 4 basically, right? Remainder is minus 4. 13 mod 17 is minus 4. So minus 4 to the power of 8, which is nothing but 16 to the power of 4 congruent to k mod 17, which is nothing but minus 1 whole to the power of 4, minus 1 to the power of 4 congruent to k, which is 1. K is equal to 1. This is not a solution. I am looking for k equal to minus 1, correct? I am trying to solve this problem. Okay, I want k as minus 1. Okay, so this is not a solution. Now let's take n equal to 2. If n is equal to 2, okay, p is 33. P is 16 into 2 is 32, 32 plus 1, 33. But 33 is not a prime. So ignore it. N equal to 3, 49, not a prime. So similarly, keep on going. N equal to 6, you get p equal to 97, which is a prime. Okay. So now try with this value. Okay. Same thing what I have done to check the remainder. You will get minus 1 as remainder, or 96. Minus 1 is nothing but 96, because now we are trying to find out mod 97. So minus 1 here is 96. Okay. So you will get 96 remainder. You have to do exactly same as what I have done here basically. Okay. This one. So answer is n equal to 6. You get actually the answer, which is nothing but the odd prime factor of 2019 to the power of 8 plus 1 is nothing but 97. This is the odd prime. Okay. So this is how Euler's totient function is helpful for us actually. So this is a new concept which is very much useful for all the students who are going for Olympiad. Okay, hope this video is helpful for you. Thank you. Keep doing maths, practice Olympiad more. I'll come up with more videos on Olympiad as well as other engineering entrance videos. Thank you.